So we're starting our new topic, circular motion and gravitation. So first we're going to look at the basics of circular motion. So the things we have to recognize is that when you have something traveling in a circular path, the velocity vector is always tangent to the circle. So it's perpendicular to the radius. That's 90 degrees right there. So that's our velocity vector. So as it travels around that circle, the velocity is going to always be perpendicular to the radius. So tangent, 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 tangent. The tangent to the circle. So what that means is if a ball, like we saw in class, if a ball is traveling, marble is rolling around the inside of a hula hoop, and we're to lift the hula hoop, say the marble is at this point right here, and lift the hula hoop, the marble will roll in that direction. Okay, so if we scroll down, so the centripetal, it's a center-seeking force, and therefore centripetal. So centripetal is center-seeking, so centripetal acceleration, the center-seeking acceleration. And later on we'll look at centripetal force, which is a center-seeking force. So here we are again. So velocity is tangent to the circle. So interesting thing about circular motion is that the acceleration is, even though the speed is constant, if we're talking about uniform circular motion, the speed is constant as it's going around, the velocity is constantly changing. But that's because the acceleration vector is perpendicular to the velocity. So the acceleration vector always points towards the center. Okay, so acceleration vector always points towards the center of the circle. So because this acceleration vector is perpendicular to the velocity, it doesn't actually change the velocity, it doesn't change the speed of the object traveling in the circle, but it's constantly changing the direction. So when the object gets over here, the velocity is still the same, but at this point the acceleration is still perpendicular to the velocity is still perpendicular to the acceleration. So just to say it again, velocity. So velocity vector is always tangent to the circle. And the two vectors are always perpendicular for uniform circular motion.